Hello, everyone. This is the first international seminar of ABREN. The title Waste to Energy, the Context of the Circular Economy. I'm Yuri Schmitke, I'm the president of ABREN and president of WtERT Brasil. I have a master course with public policy and law. I have written a book on waste to energy as an environmental appropriate form from disposal of municipal solid waste. And now I would like to call my friend, Mr. Rubens, our vice president of ABREN, secretary of WtERT Brasil. He's a Brazilian Switzerland citizen, Bachelor of Chemistry from Zurich, and have experience on financial and environmental sectors. Thank you, Mr. Rubens.
Thank you very much, everyone. Obrigado primeiro pessoal do Brasil que está assistindo. A gente vai tocar aqui em português rapidamente, mas vamos voltar para o inglês, falando para o nosso público que está da Alemanha e principalmente dos Estados Unidos nos escutando. So, thank you once again, Yuri. I was just doing a quick introduction here for our Brazilian public. First of all, it's a pleasure to have here Mr. Professor Tamilis Antanos from New York, Columbia University. It is also a pleasure to have Peter Kurt also for the European Federation of Waste and Sewage and Circular Economy. I think this webinar comes in a very important time of reflection, what we are dealing in the world, not only in COVID, but also in Brazil as a very big country. Just a few data here, we have around 210 million people. We produce 200,000 tons of waste a day. And that means around 78 to 80 million tons of municipal solid waste every year. Our recycling rates are around 3%, which are very low if compared to other countries. We still rely very much actually on landfills and dump sites. That causes diseases. We spend a lot of money and pollute a lot of the environment. So I think the important discussion here today is to see what have countries like the United States, what has Germany, Europe in the general context done, and why are they so different, and how can we maybe follow the steps, copy a bit, try to do, and also improve that to our reality in Brazil. So thank you very much for everyone who is watching us here from all around the world. I'll pass the word back to Yuri, and maybe people feel free later to do some comments and questions to our participants. Thank you very much, everyone. Yuri.
Thank you, Rubens, very much. To talk about the plans of the EU concerning the Green Deal and the circular economy, I will invite the Peter Kurz. He's the president of European Federation of Waste Management and Environment Services, FIED, and president of Federation Association of the German Waste Management Industry, BDA, members of the Presidium of Federation of German Industries, BDI, member of the advisory board of German WtERT Partnership, member of the advisory board of Deutsche Bank, bachelor in law and political science, both in Bonn and in Freiburg, state minister of finance, senator in Berlin until 1999 and 2001. Peter Kurt, it's a great pleasure to have you with us and to talk about how energy recovery can help the economic circular in Europe. Thank you very much. You just have to open your microphone.
It's better.
Yes, okay. We can hear you.
Okay, sorry. Germany tries to be a pioneer state concerning recycling and waste management. We are definitely not concerning digital communication between continents. So I think, Yuri, I need your help to start with the slides now. I would like to give you a short overview first about the two associations. Are you able to see the slides?
Yes, I'm open now.
Okay. So, sorry.
Yes, okay. That's good.
You have it?
Yes, I have it.
I don't see it on the computer, so... Okay, now I have it. Great. Next slide, please, is the overview about BDE, the German Association for Waste Management and Recycling. Here you see our new building in the heart of Berlin. We are very proud of it. If you come to Berlin, please don't hesitate to come over for a cup of coffee. We have more than 750 companies as member in our association, and we work with 500 experts, practical experts from the different streams and of the different sectors of our business to consult the government, the politics, the parliament, and the public. Next slide is the European Association, WtERT. Here the situation is a little bit more complicated because the situation in Europe is not the same. We have a lot of countries still working with landfilling. We have a lot of countries with high rates of disposal. We have a lot of countries which have not satisfying rates for recycling. More or less you can say Scandinavia, Germany, Austria, Swiss, Benelux are the hard group for recycling. The rest is more or less on the way to this. But you see all over Europe that waste management is one of the fastest growing business sectors creating jobs. We expect that if all of Europe would have recycling conditions like Germany, we would have 1.5 million people more working in the jobs of the waste management. Next slide, please. It's the global challenge Ruben mentioned. Waste management, to work with the waste, is one of the big challenges all over the world. We have, next slide, please, recycling, and this is the estimated increase of the waste by the different regions of the world. The dates we have from World Bank, unfortunately 2016, the latest numbers we get. And next slide, you see that in the different regions of the world, we have quite different situations concerning how we work with this. We have incineration, that classical is waste to energy, more or less only in some parts of Asia, Europe, and Northern America. In the other regions, recycling is not playing an important role, but landfilling and open dump is the main solution, which we all know is not really a solution for treating waste. Next slide, please. We see the hierarchy. This is a European law. The waste management hierarchy means first level is to prevent waste. This is the main goal, also for our companies working with waste. Second level is preparing for reuse. To repair some things, furniture, cars, etc. And the third level is recycling. Then we have recovery. That means in Europe, it's the waste to energy plants. And the last level is disposal, which we try to avoid in the future. But the reality is we are not able to be completely independent of disposal. The latest, the newest waste statistic from Germany, next slide, shows that it's possible also with GDP, which is a little increasing, population increasing, and the waste, the different waste streams is a little is interesting to see. Commercial waste, this is the waste from the industry, is since I think 15, 16 years constantly decreasing. The biggest waste stream by far is construction and demolition waste, 220 million tons each year. That means more than 50% of the waste we collect is construction and demolition waste. Much bigger waste stream than, for example, municipal waste, which is at about 10-15% over the last years. And now I come to the to our challenge that we, next slide please, that we try to establish, to bring the situation from waste management to really a circular economy. This is the right side here on the slide. We have recycled, no, back please, again. We have the whole circle beginning at product design, production, commerce, consumption, collection, sorting. And this is what we understand as circular economy. And this circle shows very clearly that you can't avoid one part of the circle to have a convincing solution, what we call circular economy. And the main role has to play the producer. And so we are very happy that the European Commission is understanding now what we mentioned since some years. To create circular economy, it will not be enough to look on the waste management. It's important to see the producer as main responsible. And now the next slides, please. Next slide. We see the different responsibilities we have and the organization. We have private households producing waste, delivering it to the municipality. But the industry and all the other waste, the demolition waste, has to be part of market competition. We are talking about an industry. We are talking about an industrial activity. It's not possible that the cities try to create circular economy. We are talking about industrial challenges. We are talking about industrial plants, and this is definitely not the business of municipalities. So to collect the 12% of the waste coming from private household is a responsibility and the job of the municipalities. All the other is part of the industry, and that means we need fair and transparent law, which is also implemented in the daily life. Next slide, please. If we talk in Germany about waste to energy, I would say we have three points. The most important is to the incineration of municipal waste. We have a capacity of 25 million tons a year. This is more than we have as waste. So we are importing waste from other European countries to be treated in our plants. This is better than bringing them to landfills, for example, in Italy or Poland. Then we have the second field. This is the biogas. We have a capacity here from 15 million tons a year, 2,300 biological plants, bringing organic waste to biogas. And then we have a very new activity on an experimental scale. This is what we call chemical recycling, or better, what the chemical industry wants to call chemical recycling. We are not quite sure if it's really part of recycling, but let's take the name. If you have polluted plastic, for example, then it's an interesting project to bring it back to the origin status from oil, but only if then you are producing other plastic products, it's really allowed to call it recycling. The next slide is only an overview about the waste energy plants in Germany, slide 12. Interesting here is, you have the next slide? Interesting is that also in Germany, we would have landfilling today if it's not, it wouldn't have been forbidden in 2004. That means waste management and more to bring waste management in a circular economy needs the public and political support. We will not be able to do this without laws. So try to convince parliament and governments which laws our companies need is the most interesting job and activity from our associations. This is in Berlin the same as in Brussels. And now we see, next slide please, that the European Union is better understanding what in ecological modernization of our economy means. We are discussing the Green Deal, and we hope that the Green Deal is not one of the victims of the Corona crisis, but will stay on the agenda. Green Deal means stay in industrialized country, having a strong economy, but also being able to reach our climate goals, being able to change our energy policy. And this is what we call European Green Deal for the next 5 years. And we are very happy and proud that the European Union says the most interesting part of the Green Deal is our Circular Economy Action Plan. Slide 14, please. And sorry, I have here, and on the other 2 slides, the different measures which are expected for the next years. You have the dates on the right, and you have the titles of the different measures. We expect more than 30 new regulations and directives of the European Union concerning a new eco-design directive, concerning really green public procurement, how to organize that the public authorities, if they buy something, if they give orders, that not the cheapest price is interesting, but the most convincing solution concerning sustainability. Next slide, please. Otherwise, I used all the 2 hours. You see that we have a really ambitious program for the different material flows. We will start in the next week with battery, the so-called electric transport and traffic faces challenges for the waste management because of the batteries, the new one. We will have a mandatory recycled content. That means that the production is obliged by law to use recyclates as part of their production. The industry will not longer be free to choose between primary raw material and recycling raw material. We will have mandatory recycled content, and we try to bring this principle to the different fields. Textiles is a big challenge for us. We expect it for next year. And the next slides, we see that exactly. We have not only production, but that are the main activities. We will also try to harmonize the separate collection systems in the European Union. Waste shipment regulation is a very interested political activity because we need frame conditions that allow us to be compatible with other activities. We need a worldwide possibility to export and import raw materials. That means waste shipment. Which waste streams, which materials are we able to import and export? This is a very interesting point. The next slide, more or less the last one, is the cross-sectoral measures. That means that we, with financing, with emission trading, we all take under those bigger titles the different activities. So here we see the, for example, European African Partnership for Circular Economy. Very interesting because the very fast growing big cities in Africa, they have almost not recycling or waste management situation, which is worth the name. And here we try to help a little bit. We want to stop and avoid landfilling the next years. Perhaps we reach this with special taxes. Otherwise, we need a landfill ban for the European Union. This is our biggest wish for our German government, which is having the EU presidency beginning at the 1st of July. So if I now come to the last slide, we see that we understand circular economy as one industry of the future. With such a circularized economy, we would be able to save and protect resources. We are able to have another energy policy, and this is absolutely necessary to fight the climate change. And these are the last figures I can give you. We are able to, as waste management and recycling sector, we are able to be delivering the biggest part of the CO2 emissions we have in Germany. And I think this could be also an interesting way for other countries and other regions in the world. The first steps is building up a waste management situation, and then with the responsibility of the producers, also the development of waste management to circular economy. I hope it was able to understand me. Sorry for the technical problems. Yuri, thank for your assistance. It was a pleasure and honor for me to be invited to take part at your webinar. Thank you.
Thank you, Dr. Kurt. It's a pleasure to us to have this presentation. And now I will call for the Dr. Temlis to be our speaker. Dr. Temlis is the founder and the president of Global Waste-to-Energy Research and Technology Council, Global WtERT Council, founder and director of Earth Engineers Center, and chair of the Chemical Engineer from Columbia University, bachelor, British Association Medal for Great Distinction, and PhD degrees from McGill University, Montreal, Canada, in chemical engineer, author of over 200 technical papers and 5 books, and holder of several patents on metal extraction and refining. Dr. Temlis will talk about the importance of waste to energy to sustainable development in Brazil. Dr. Temlis, you have the word, please. You can share your screen also. You have to open your microphone in the symbol on the bottom. Microphone bottom. Temelis, just go to the bottom, the symbol of microphone in your Zoom. Okay. But you have to open your microphone, Dr. Temelis, not open. The presentation is open.
Yeah.
Okay.
Why?
That's great. You can hear. You can start.
Fine. You hear me, but the slides is the wrong slide.
We'll just have to come back.
Let's see. The usual way. Frozen. I don't understand why the slide.
Keyboard, you just have to go to previous. You have the button.
Yeah, I saw. New share. Yeah, but let's see. Why does it not go to? All right. Okay. I'm sorry. I'm in the first slide. Sorry. Okay, I'm a beginner on this. Thanos is much better. Many thanks to Mr. Kurth. It's a very, very clear and very interesting presentation, especially when he says that Germany produces 400 million tons. This, of course, includes all the residues of activity, but it's amazing how much, because as he said, municipal solid waste are about 50 of that only. All right. I'll speak specifically about the technology which has been developed for the last very well 40 years. And it's essential technology for what we call sustainable waste management. And it's a one that could be applied in Brazil. I want to thank Mr. Yuri Schmitke and ABREN for inviting me and for taking over the responsibility of WtERT Brasil. By the way, I will have Mr. Kurth introduced to the head of WtERT Germany, Werner Bauer, who is very active and has lots of ideas. Why does it not change?
I have a button in the down of the screen.
All right. Oh, yeah. All right. Okay, I put this thing in Portuguese just as a kind of a homage to the host. What I say is that more or less what Mr. Kurth said, that all the cities and nations are looking for economic development. But economic development is accompanied with consumption. This is the disadvantage. And consumption is accompanied with residues of activity. So what has happened is that enormous amounts of waste are being generated, and humanity or nations have to find how to deal with it. Now, the obvious way to do with urban residues is to try and recover, recycle. My talk will be specifically about municipal solid waste and post-recycling waste. In other words, you try to do as much as you can to recycle and compost, and Germany is doing a very good job on that. And then you have two choices, either to landfill or to go to a waste-to-energy plant. We don't call it incineration in America because it has a bad name. And also there are thousands of incinerators in the United States, while there are only 72 waste-to-energy plants. There are incinerators for crematoria, for medical waste, et cetera, et cetera, et cetera. So what the obvious thing to do with urban residues is to recover, but it has to be done economically and environmentally consciously. What I'm saying about this, if you use trucks and machines and so on to recycle things, the environmental impacts of those have to be added to the total cost to assess it versus energy recovery. recycling, you know, in the United States, I'm very impressed with Germany. Of course, this talks about urban waste, not all the waste, not construction, demolition, and mining, and this and that only. And you can see that in the United States, it has reached a level for many, many years. The recycling has not changed much. Waste to energy also has not changed, and we can discuss the reasons in the United States. So landfilling has remained high. It's about 60% landfilling. So the conclusion we have reached, not only from the United States, but working in many countries as we do, and having students, graduates from several countries, is that after all possible recycling has been done, there remains the post-recycling waste. Post-recycling waste. In Brazil, this constitutes about 80% or over 80% of the total urban waste. So the word I looked at the word in Portuguese is post-reciclagem, urban waste. Can either go to landfills or they can go to waste to energy power plants. This is it. Yeah, there can be a small amount that go to some other places, pyrolysis or this or that, but the two principal routes for treating post-recycling waste are landfills and waste to energy plants, universally. This is a picture I took myself on the island of Mauritius about 15 years ago. I was asked to look for waste to energy, and it made great sense, a waste to energy plant, but it has taken 15 years for it to go up. It's going up now in Mauritius. But here you see a landfill, a forest, a beautiful forest being converted into landfill. And this happens in many, many countries, of course. Now, the dominant technology of waste to energy is what we call a moving grade. I won't spend any time on that. You people are aware of this. The wastes go as they come, as they arrive, they go into a furnace. There's alternatives. There is a fluidized bed, but it has not been as pronounced, as advanced in use as moving grade. And why? Because it's simpler. You don't need to do anything. Now, the screen here, I don't know how you can make it smaller, but what it shows is, it does not show it complete, but the full slide shows 100 cubic meters of waste. The two piles that you see together, they come 100 cubic meters. And on the very right, you can see a small pile, the ash, 10% of the ash. So you convert, and you also produce electricity. So you get 100 cubic meters, and you get 10 cubic meters of ash. And Professor Burtsalas may say something about that, what can be done with that. This is a plant in Lancaster County. I picked that because this is an exemplary community in the United States. They have their waste, they have recycling, they do a lot of composting, and they have recycling. They're like Germany. They don't do any landfilling. And this waste to energy plant is in one of the most scenic areas. You can see even in this picture, the river behind and so on. But I'll show you the next picture. You know, farmers markets, people go to Lancaster like they come to Cape Cod. You know, it's kind of a beautiful place to go to, despite the fact that it has a waste to energy plant. We made, Thanos and I have made this picture here, which shows recycling and composting in all the countries that we could get data from. What do we have here? At the top is from 0 to 100% of the urban waste. Where does it go? And if it goes to green, that's recycling and composting. If it goes to red, if it goes to waste to energy, it's the red. And unfortunately, a lot of the European waste and other countries goes to landfilling. That's the brown. You see all the brown here? And I'm ashamed to say United States is not a good example in that sense, because we still have 60% landfilling. And we can discuss the reasons for that. There are no economic or environmental reasons for that. Simply some prejudices, and economic in the sense that it would cost a community $20 more a ton. It's nothing. That's $20 for a country that has a GDP of $60,000 annually. But it's one of the aberrations in the United States. We look for the application of waste to energy in Brazil. And I use data in the United States. I mean, it would take time for Brazil to get to this point, but that point, it's not going to be so good. They need more waste to energy. The estimated final use of land for landfilling is 1 square meter, this is globally, for every tons of solid waste. Sanitary landfills can go a bit higher. We have figured out with Dr. Boutsalas, 15 tons or 12 metric tons. So if you have in population 210 million, you have estimated 80 million tons. I had made an assumption of 100 million. Thank you very much, Yuri. And then that would be 8, not 10,000, because for 80 million, 8,000 hectares per year. 8 hectares per year is the land surface of Rio de Janeiro in 14 years. In 14 years, the country of Brazil is using an area, total area equal to the Rio de Janeiro surface area in 14 years. In 100 years, it would be 6 times that. So it's not a sustainable use of land. There is a greenhouse potential for Brazil, for every country which uses waste to energy. We say that conservatively, you save 1 ton of carbon dioxide per ton of solid waste that goes to waste to energy. You know, when Mr. Kurz spoke, you know, said 25 million tons go in Germany alone. They go to waste to energy. In comparison, only 27 million tons go in the United States, which is, you know, several times bigger country. So Germany is doing a wonderful job. And if by this 25 million tons going to waste to energy, they save 25 million tons of carbon dioxide. Norway has assessed a cost of carbon dioxide, $40 per ton. And actually people who work on carbon sequestration, and we have some of these colleagues at the University of Columbia, they set their target $50 per ton. And they have not been able to succeed so far, but you know, now maybe $100. It's too expensive, but $50 a ton would be acceptable for carbon sequestration. Why I'm bringing that up? That means that if you, for every ton that you go to waste to energy in Brazil, or you would go, you would save $50. That has to be added, but it's not been added yet. There's electricity and materials recovery. I expect in Brazil, with the waste they have, the type of waste, 500 kilowatt hours, half a megawatt hour per ton of waste. Annual generation, that would be smaller amount now because we say we have a smaller amount of MSW, but anyway, plus ferrous and non-ferrous metal recovery, plus minerals for civil works. Professor Boutsalas may say something about that. Now, who is a better neighbor, a landfill or a waste to energy plant? I mean, all one has to do is to visit a waste to energy plant any place in the world, and visit a landfill any place. And the difference is obvious, that waste to energy plants are better neighbors. So there should not be opposition to waste to energy plants because they're bad neighbors. And if you can take a city like Vienna, the waste to energy plant is right in the middle, next to a residential area, next to a hospital. There's no reason for these plants not to go. And advantage would be over landfills is that you don't have to transport the waste by truck long distances. In Mauritius, I mentioned the island, it's a small island. I showed them how many trucks a year they use on these small roads that they could have been avoided by a centrally located waste to energy plant. And to show you that waste to energy plants are good neighbors, Professor Burchalas put together this following slide. Distance of waste to energy plants globally from the center of the city. Okay, and here we have the distance, you know, it's going up to 18 kilometers. Most of the plants, you see where they are? Here, right in the middle of the city, because it makes sense. You don't have to transport. You don't have to move from one small truck to a big truck. Now, the objective of the WTRT Council, and we are very proud to have a new leadership with Yuri and his colleagues. The mission is to advance sustainable waste management. But we're going to add now, as of this year, a very clear directive, and to promote waste to energy over landfilling for post-recycling waste. We don't want to have any argument with recycling, post-recycling waste. And you see the countries, some of the newer ones are Canada, it used to be before, now again, and Turkey. Now, before finishing here, I would like to say Brazil, like every country, I mean, people should look at what has happened and it's better than what they are. You know, I look at, you know, other professors and say, what they've done better, maybe I can do it. It's too late for me, but for Thanos, it's not. Brazil should follow another developing country, China. About 15 years ago, we showed a movie in Colombia that what a miserable situation China was with regard to waste management. Beijing had 500 landfills, were surrounded by landfills. Okay, but in 2 decades, China decided to grow to being a global economy. And they are almost there, right? They are the #2 global economy now. Since 2000, China has built over 300 waste to energy plants. And you can visit any of them, and they are as good as German plants or American plants or any other plant. The current Chinese waste to energy capacity is greater than Germany, European Union and USA added together. They have 120 million tons, 125 by now. While US has only 27, we said. By mass production, another thing, by mass production of waste to energy plants, by building plants all the time, let's say needing to build all the plants, these plants are much less expensive than the German plants, who are very good plants, but you know, every time you build one, it's like before Ford, you built one car at a time. It's very expensive. Ford came up with mass production and the cost dropped. Chinese plants, they are able to be built at about 1/3 of the capital cost per ton. And if they are built abroad, if they are built in Brazil, we think it would be about 1/2 at least of what the present waste to energy plants in Europe and the European Union, in the US cost. This shows you the growth of plants in China. You see, the smallest year, 1998. And you can see what has happened. In the full chart, they have the tonnage and the number of plants. Well, okay, I think that's, Yuri has cut off all the photographs. That's good. Thank you very much. This completes my presentation. Oh, 1 second. No. Yeah, no, this completes my presentation.
Okay, Dr. Temes, I have to thank you very much for the presentation. It's been an honor to represent WtERT Brasil, to represent our institution that have in development waste to energy all around the world. We can have, we need your help to the technical studies, and we are planning to make a national guide, and waste to WtERT will be very good to help us to develop the studies, the financial models to show to the politicians, to the administrations, public administrations in Brazil, what's the best manner to treat the waste, that it's possible, it's feasible, and that we can change the situation in Brazil.
Yuri, excuse me, I thought you had cut off the slides, but you had not. Very quickly, I'll go through the photographs if you don't mind. Here is one plant in Nanjing. You see Professor Burchalas proudly standing in front, and they do have this, you know, it's like a Lincoln Center in New York, the water fountains. It's very beautiful inside and out. This is what the plant looks for the operators, you know, where the operators, they can watch the camera and everything. They are outside the plants.
This is the plant.
Yeah. What happened? Oh.
We can see in the screen. I put for you the presentation.
All right. So anyway, all right. Let me just see if I can go.
No problem. I can change it for you.
Change. Go hard. Go next. Go next. Okay. Oh no. I'm sorry. Go back to the previously. One more. One more. Yeah. Outside. No. Let's stick to that other one. Go. One more. There. You see the.
Yeah.
One before that.
Before. Okay.
Yeah. All right. This is a neon sign outside. It's a lot of plants, Chinese waste to energy plants, where the citizens can see continuous monitoring of various emissions. Next slide. Next. Okay. One more. There. This shows why the Chinese plants are less expensive. This is a plant manufacturing the discharge, the parts of the waste to energy plant by mass production. And you know, this is Everbright China, fabric of equipment of waste to energy. Next slide. Okay, this is the guidebook. We have a guidebook. You mentioned, thank you, but one more. Yeah, we have it in Portuguese. Everybody can read it in Portuguese. We have it in Spanish also, but Portuguese is it's a guide which gives you a lot of information about recycling, composting. It's not only waste to energy, but has a lot on waste to energy. And last one. This is a plant in Brescia. It's kind of the showpiece, and it got an award from us in 2006 as the most beautiful and most efficient waste to energy plant, because they use energy, the heat, the waste steam to district heating. This is in Brescia, Italy. Unfortunately, southern Italy still needs. Next. In conclusion, and looking from outside, I didn't want to miss this one. With discipline and dedication of the people, of the citizens, Brazil can turn itself to the next economic power. I mean, you have the land, you have the population, you have the resources. There's nothing stopping you. And in terms of waste management, also go to at least to some waste to energy instead of landfilling. Thank you very much. Okay.
Thank you very much, Dr. Temlis. Sorry for the to share the screen, but everything is okay. Thank you very much. I have to the speaker now is Dr. Tenas Bortsalas. He's the Vice President of Global WTERT Council, lecturer in Energy and Minerals and Earth, Environment Engineer, Columbia University, Bachelor Engineer and Master Engineer in Electrical and Computer Engineer, University of Patras, Greece, Master in Earth and Environment, Columbia University, and PhD in Civil Environment Engineering, Imperial College London, more than 30 publications, articles, technical reports in the field of sustainable development. Dr. Tenas, please have the speak. Let me open your microphone.
So thank you very much, Yuri and Rubens and the WTERT Brazil team for giving me this opportunity to speak with you today. So the title of my presentation is about the role of waste to energy in a circular economy society. Before I start, to give you a brief introduction about our organization, that the WTERT, which stands for Waste to Energy Research and Technology Council, and it was established by the Earth Engineering Center of Columbia University in 2002. The aim of the organization is to identify the best available techniques for the recovery of materials and energy from all types of waste materials, the urban and industrial residues, and also to disseminate this information by means of publications, the multilingual WTERT web pages, and several actions we are doing in communities. To put it simply, we're a bridge between the academia and the industry, and we're trying to promote what makes sense in terms of recovery of energy and resources from the urban and industrial residues. At the moment, we do have, roughly speaking, 15 sister organizations around the world who have been really active in Latin America, Europe, as well as in Asian countries, with main focus also in China, Japan, etc. So what's the main problem about waste management and the waste that's being generated? According to a study by the World Bank, our world will not reach a peak by 2100 in the waste that it will be generated. So at the moment, the world produces, roughly speaking, about 5 million tons, 5 to 6 million tons of waste per day. And this number, in the worst case scenario, is expected to go up to 12 million tons per day by 2100. But even the most optimistic scenario implies that our world will have to face about 9 million tons of waste per day. We have a relatively new concept, the circular economy, which implies that we want to move from a linear economy model, from a mixed technical and biological materials cycles, to biological nutrients, and ideally to optimize the resource efficiency of processes. However, when the discussion goes to the urban environment and what can really be done, earlier Professor Peter mentioned about the 3 R's or the 4 R's: reduce, reuse, recycle, and recovery. The Earth Engineering Center developed some time ago the hierarchy of sustainable waste management, where we took into consideration the several techniques. And we easily realized that eventually we're talking about 2 major streams: the materials that can be recovered and recycled as another resource, and the materials that do not have any value in the market. And for this type of materials, eventually you have only 2 options: either waste to energy, with the dominant and proven technology being combustion-based waste to energy, and the several forms of landfilling. It is really important to recover resources for the sustainability of our planet. According to Professor Themelis, many years ago, after the Second World War, this is actually the story of copper. In the y-axis, we have the years after the Industrial Revolution. And on the y-axis, we have the refined copper consumption in million tons. As you can easily see, and the same rule actually applies to all the materials of our humanity. As you can easily see, after the Second World War, the consumption of copper increased from about 2 million tons up to 11 million tons in 1995, and this number doubled in 2015. So it hasn't been for the recovery of copper from the several waste streams, two things may have happened. Either the world would have run out of copper, or the price of copper would have been significantly high. What are the typical and necessary ingredients to achieve high recycling rates and successful recycling in communities? We need actually communities with separate collection of materials, citizens who are very well aware about the different waste streams and are really keen to separate materials at source, and very important, if not the most important, to have markets that can use and make profit from recycled materials. Because if a private entity or a public entity invest in a process, they will expect an equivalent value from the market. However, in reality, things are not really that promising. So what do we do actually to increase composting? We have two possibilities. Either the least costly, where the municipal governments provide the window composting center, and people are going there and dispose of the resource separated materials, or the more costly, which is an anaerobic digestion, low efficiency. You can recover really low amount of energy. However, this can be a good solution for food waste materials. However, for all this, it's really important, and the key is to achieve high source separation of the materials. According to our associate, Mr. Anepu Ranjit, who did a study for the case of India, and he examined the effect, the impact of source separation on the heavy metal concentration in the recovered municipal solid waste compost. Here we have actually heavy metals, zinc, copper, cadmium, lead, nickel, and chromium. And on the y-axis, we have the concentration in three different scenarios. The one was just one bin in the community where it was receiving mixed waste materials. The second bar, the red bar, is the partially separated materials. And the green bar is actually an optimum source separation of materials. As you can see, we have a significant effect. And in reality, we cannot really achieve optimum source separation of the materials. So eventually, it is not really possible to collect all recyclables or even to process all waste to marketable products. For example, in a typical example, it was a study that was done by Professor Themelis a few years ago. In California, a very green state, after many years on efforts that they were trying to increase recycling, they managed to increase plastics recycling from one stream, and they managed to do only by 10%. So the rest 90%, even after spending a fortune, campaigns, trying to disseminate the information, the rest 90% was ending up to landfills. So eventually they were back to square one, as they were saying as kids. So therefore, it has become necessary universally to develop pragmatic solutions for disposing properly the post-recycling waste materials. And as I mentioned earlier, we do have two possibilities. Sanitary landfilling with methane recovery that will protect ground and surface waters as compared to the improper waste management, open dumping. It will cut down greenhouse gases, again, as compared to open dumping, by about 0.5 tons if we have advanced methane recovery. And it costs, depends also on the landfill and the location, in between $100 to $200 per annual ton of waste materials. However, even if we have a very proper landfill, a sanitary landfill with advanced methane recovery, still we will have the consumption of land, as Professor Themelis mentioned earlier, roughly speaking, is about 10 tons per square meter, 10 tons of waste, and combustible or compostable wastes, like plastics or food waste, biodegrade slowly and release methane gas, mercury vapor, contaminated water long after the landfill is closed. And obviously, as I mentioned, consumes a lot of land. This actually goes back the discussion to what Professor Themelis mentioned about a film for the case of Beijing, the capital of China. And these yellow pins are actually the open dams and the landfills that were surrounding Beijing sometime in mid-zeros. And this is actually a photo that I took a few years ago. And this is actually a sanitary landfill, an advanced landfill that recovers methane and produces electricity. Even so, it consumes a lot of land and it's not actually aesthetically pleasant for communities. The other option we do have, again, I will not talk about pyrolysis or gasification because these technologies for the mixed waste materials are not proven yet. Combustion is a proven and dominant technology. We do have, roughly speaking, 1,000 plants around the world. As it was presented earlier by Professor Themelis, most of these plants are located within the urban environment, on an average 5 kilometers from the city center that these plants are serving. And the very first plant, combustion-based waste to energy, was built sometime in the late 60s in Europe. So all that being said, we're talking about a really proven and dominant technology. And what I'm saying, if, for example, a Danish guy or a French guy never had a problem with a waste to energy plant, and we're all coming from this African DNA woman, so why actually a guy in Brazil or New York or wherever in the world would have a problem? So waste to energy can recover electric energy in two forms, either electricity or district heating and cooling, and from the residues, especially from the bottom ash fraction, which is roughly speaking 20 per weight % as compared to the combustible material, you can recover metals as well as minerals. That is why we're talking about waste to energy as well as resources from waste. A typical waste to energy bottom mass recycling plant doesn't differ that much from what we know from the MRFs, especially on the upstream and the recovery of the metals. They're using conventional equipment, magnets and eddy current separators to recover a significant amount, especially with the recent advanced European developments. These numbers on the recovery efficiency are up to 90 or even 95%. And after appropriate screening, the mineral fraction is being used typically for bituminous applications, for asphalt production, for civil engineering products. To give you an example, in Denmark, the A12 highway that connects actually, I think, the airport with the city center, the wind barriers, the noise barriers, as well as the highway is being built by these materials. Similarly, in the Netherlands, UK, and many other European countries. And also now we're doing a significant effort for the US. By now, I mean, the environmental superiority of waste to energy has been accepted universally. There is no question about the superiority of waste to energy. In the COP21 document, waste to energy is considered to be one of the most prominent techniques to recover district heating. We have actually regulations in the US. Professor Themelis mentioned earlier about this phenomenal growth in China. We have actually the announcement of new plants in Addis Ababa, Abu Dhabi, Hong Kong, etc. But why still so much landfilling? For two reasons. One is the old hat of incineration emissions and this misconception of the terminology, incineration and combustion. Again, as Professor Themelis mentioned earlier, we do have 100,000 and even more incinerators around the world, whereas we do have only about 1,000 waste to energy combustion-based plants. And the second is the capital cost that used to be relatively higher as compared to landfilling. The public acceptance of waste to energy, and that is why also the role of WTRT in communities is very important. It's the continuing opposition of waste to energy based on early history of incineration, and a typical argument by the opposition associates with dioxins or the emission of dioxins that will be harmful to public health. According to our inventory studies, this actually is a comprehensive. We collected data from the industries, and we did an inventory study for the case of US, France, South Korea, and China. This actually in the third column, we have the MSW, municipal solid waste, processed in these countries, and the average dioxin emissions. The limit is 0.1 nanograms toxic equivalent per normal cubic meter. As you can easily see, all of these plants are emitting a 10-fold to 100-fold, even lower than the national established limits. According to a study that was done by Professor Themelis, where he compared the dioxin emissions from the waste to energy plants and other industrial sources, and with the implementation of the very strict standards in the 90s in America, as you can see, this had actually significant effect in the reduction of dioxins emissions from these operations. So back in 1987, waste to energy was contributing up to 59% to the total dioxin that were emitted back then in the States, whereas in 2012, this number dropped down to 0.08%. And because, as I mentioned earlier, we have these two gladiators, waste to energy and landfilling, when Professor Themelis compared waste to energy and landfilling from unintended landfill fires in the US, out of his big surprise, and my big surprise when he mentioned this to me, in total, landfills, the unintentional fires from landfills, emit 1,300 grams toxic equivalent, as compared to, roughly speaking, 3 grams in total from waste to energy operations. So again, we're talking about very, very safe operations that have never ever affected the communities. I would say actually quite the opposite. Usually, I mean, when you have a waste to energy plant in your community, usually you're actually, as Professor Themelis also says, we have actually a marble in our community. So it's actually a great advantage. We compare actually the carbon dioxide emissions, and don't fall in the trap and compare waste to energy with other energy sources, because waste to energy is a waste management technique that can recover energy. But even so, if we compare waste to Professor Kaplan many years ago, he compared the several forms of landfilling as compared to waste to energy. In England, we call it EFW, stands for energy from waste. So you can see we have a significant reduction, as attenuated, because from landfills we have the emission of methane, which is a very potent greenhouse gas. But even if you compare EFW or waste to energy with other energy sources, we have a great variability in the feedstock. That's why you have a high standard deviation here. But even so, it can produce actually lower CO2 or similar CO2 emissions to other energy sources. And at the end of the day, it's not something new. Let's see actually about some great examples and how they managed to achieve the so-called sustainable waste management and the so-called how to move away from landfilling. This is actually a study that we did recently. And as you can see, here we have like the years since 1995 until 2017, the European data that we analyzed. And here we have on the y-axis municipal waste treatment in kilograms per capita. So as you can easily see, Europeans moved away from landfilling by a combined effort of composting, recycling, and waste energy. In the same period, landfilling was reduced by about a half, waste to energy was increased by about a half, and recycling by about 3 times higher. And recently, also the Europeans introduced the circular economy package, and they set up actually and they defined really ambitious targets for 2035. But according to a recent study by CEVEP, the Confederation of Energy from Waste Plants in Europe, if we assume that in 2035, and this actually from a model that these guys developed, we will have, roughly speaking, 246 million tons of municipal waste and another 295 million tons of non-hazardous, non-mineral, commercial and industrial waste. Out of this, and with the European targets, ideally, in ideal conditions, we will actually achieve a recycling and composting of 65%. This is also in accordance to the European document. Whereas from the other stream, with advanced sorting, advanced collection, and obviously, as I mentioned earlier, you need special ingredients in the communities to achieve such techniques, you will have like 68% of recovery. So that being said, and with regard to that model, which makes absolutely sense, even with these very optimistic and ambitious targets by 2035, waste to energy will play a key role in this circular economy society. And roughly speaking, we attenuate 25 to 35% to be disposed of properly in waste to energy plants. Roughly speaking, 90 million tons, according to this model. As I mentioned, another bottleneck of this technology is the cost. However, as we all know, I mean, with regard to the massive implementation of technologies and the economies of scale, usually when you have a mature technology, the capital investment, at least on dollars per annual ton, as being reported here, you will expect to reduce. And this was actually the lesson from many, many Asian countries that the role of the public policy to reduce the capital investment, if you have politicians and public entities, governmental authorities really keen to introduce and deploy waste to energy in their communities, then also capital investment will be reduced significantly. A typical example, from my view at least, is the case of Dublin in Ireland. In Dublin, recently, a couple of years ago, Covanta opened a plant. However, this plant was commissioned sometime in 1998. And because of the public opposition and the capital investment from about $500 per ton went up to about $1,200 per ton. So that being said, the role of the public entity and the governmental authority is significant to reduce and mitigate also reduce the capital investment and mitigate the risk, as well as provide security to the investors. And you saw, I presented earlier a few photos of landfills. So let's have a look also on the situation of waste to energy, since again, we're talking about these gladiators. So this is actually a newly built plant in Copenhagen, where also they have a ski slope on top. You may have seen it is located exactly in the city center. And again, Danish people never had an adverse effect by waste to energy. Spitalau plant in Vienna, which is located right next to the Palace of Vienna. And also you have to pay a small fee to enter this plant. And it's considered to be also one of the top 10 sightseeings of Vienna. Leeds in the UK, in Midlands, where it's actually a green building, and many others. So the general conclusions and why waste to energy is vital for circular economy. From our experience, for 6 reasons. It produces energy from waste that cannot be recycled, and it is typically landfill. You may have heard people claim that why waste to energy and not 100% recycling? Because this is against the second law of thermodynamics. If you assume that we are targeting 100% recycling, immediately you are assuming that you will have a process that it will be 100% efficient. So immediately you are assuming that Newton was not right. Second, successful examples of the world have proved that recycling goes hand in hand with waste to energy. You saw earlier the European example. You saw the ladder of sustainable waste management that was presented by Professor Themelis. You saw also the situation in Germany, one of the pioneers in this field. WTE waste to energy is key to remove hazardous components from the circular economy cycles, which is also one of the major priorities of circular economy society, to substitute the chemicals and to remove all the hazardous materials from our cycles, allows recovery of metals and minerals, saves land and greenhouse gases, and at the end of the day, the terms or cycles in a circular economy need energy that can be provided by waste to energy. So again, thank you very much for the opportunity, and it will be all my pleasure to answer any of your questions or concerns.
Thank you very much, Dr. Thanos. Now you can have the question answers, 20 minutes or maybe one more. And I'd like to give the word to the Rubens. Rubens, you have some questions to say. I know to 80 questions on the YouTube Live. Thank you very much, you that are here in YouTube Live. If you want to make some questions, it's your time. Just open your microphone, Rubens. Okay. Thank you, Dr. Teros Bortsalas, very much. Good presentation.
Okay, yeah, thank you very much, Yuri. Well, thank you very much also, Mr. Kurt, Mr. Themelis, and Mr. Bortsalas. I think those presentations were very, very helpful to better understand the context of waste to energy. I think most of the myths that we are usually here confronted in Brazil were clearly exposed, and that's with science, with regulation, with public support. And I have a few questions, and I would like actually to start with Mr. Kurt, if possible, because he talked about regulation and public opinion. And I think nowadays, as we were seeing the graphs and how waste energy supported better recycling rates and all of this, and I think that's maybe probably our biggest challenge in Brazil nowadays. Mr. Kurt, how do you see, what was the experience to have better public opinion and public support? Because I think you cannot really change a society, even though there's technology and great technology, as we have seen here, the cases of China, United States, Germany, France, Italy. How do you see a way, or the best way in your case, or European view, to better engage the population and have public support in order to change the status quo, as you have moved and you have this great success case in Germany? How do you see that? Sorry, I think
I open the microphone. Just have to open the.
Now it works. Now it works. Okay. The best examples, or to convince the public opinion, most important was that people see working. Sorry to say, incineration plants. I should use the new word, waste to energy, in their neighborhoods, without problems of air pollution or something else. This is clear. You have schools, you have gardens, you have people living nearby waste to energy plants, and there are no problems. This is very well known. Second step is to show that we only have two alternatives, either landfilling or waste to energy. It will not be possible to recycle everything. This doesn't make sense from the ecological side, and it doesn't make sense from the economical side. For example, you have polluted waste, you have waste which is such complex that you can't pay the recycling process. And so the alternative, landfilling versus waste to energy, clearly waste to energy was the winner. And so we only have the remain problem of the costs. Many cities, many regions are the owner of landfills, and they earn money with this, and they think they lose this income if the landfill is closed. So we have to see who is the profiteur of the actual landfilling situation and how to convince him. But again, I repeat myself, without a law to forbid landfilling, not today, but in 5, 8, 10 years, it will not work, because landfilling is always the cheapest solution. If we don't take in mind the external costs. So, and I think we need both. We need the public process of convincing politicians and people that waste to energy is better than landfilling, and we need more efforts for the recycling qualities. I think we shouldn't go too fast to say we have recycling and post-recyclable waste, and that's we bring into the waste to energy. No, we need better recycling quotas. And that means we need, that's what we call circular economy, the responsibility of the producers, because you decide at the design of a product if the recycling can work or not. If you have a packaging for cheese or something like that with 7 or 8 different plastics, recycling will not work. But we have to change the way we produce to bring better recycling qualities. So we need both. More efforts for a better recycling society, and a very clear public debate that we have to stop landfilling because of different reasons. If you take all the landfills in Russia, for example, you have an area which is as big as the Netherlands, only landfilling in Russia. That's the point we have to discuss, and I think we can be successful with this.
Thank you, Mr. Kern. I have a question, Penido, a question for Dr. Temelis. Do you think, Dr. Temelis, that the low prices of oil could affect the economic feasibility of waste-to-energy plants?
Yes, there is waste-to-energy depends on two sources of income. One is the gate fee, the tipping fee, the gate fee, the bringing the material in, and the other one is electricity. And if oil is very inexpensive, then electricity becomes inexpensive, and there is less income there. If one does not include the external costs, like the carbon dioxide, that, as Mr. Kurt said, landfilling is actually in the US is one of the most profitable businesses. I looked up, when we were making a study with Thanos, I looked up what is the cost of land. Suppose I want to buy land, not to build a house, but in the open country, some place where I can build a landfill. It was $1,500 an acre. Let's say that's half a hectare, $1,500. And out of that, you could landfill times 10 times the square meter you could get $1.5 million. The investment, of course, you have to make more investment in buying the land. You have to do something, but the investment is minute in comparison to the investment for a waste-to-energy plant. If you only look at it year by year, if you look at it over 30 years, you may come up to a different conclusion, because at the end, the waste-to-energy plants can go for 50 years. So I don't know if I answered your question, but that's what I've said.
Yeah, that's great. That's great. Dr. Temelis, I have another question. One of the slides in the presentation, a reduction in the volume of raw material for final disposal is shown. I suppose there is no organic material in the raw material. Am I right? Carlos Souza.
When you talk about organic materials, you can separate them in two. One is green, call them green waste. Okay, garden, park waste, green stuff, no food, no meat, no other things. That could easily go to aerobic composting. Aerobic, it's the cheapest, it's a very cheap way to do it. And in the United States, about 50% of the green waste go to such an aerobic. But when you have mixed waste, like a kitchen waste, that cannot go to aerobic because it creates smells and stuff. It has to go to anaerobic, which are chemical plants, and they cost as much per ton as a waste-to-energy plant, or more per waste. I give you an example. In Vienna, they built a fourth waste-to-energy plant, and right next to it, they built a small composting, aerobic digestion. One was for 250,000 tons, and the other one was for something like 18,000 tons. And it didn't make economic sense, but it was done because, as the Minister of Environment of Vienna told me, to satisfy people to do some recycling or some. That says didn't make sense, because people at restaurants, they had to separate that food, then special trucks to bring it to this place. And when it came to that place, it had 30% residue, 30% still plastics, whatever it is that they could not process. And the residue went to the waste-to-energy plant. So overall, it's difficult to justify anaerobic digestion of source-separated waste. In New York, they are trying it, but it's difficult to collect. First of all.
Peter Kurt, Vitor Torres answered, what technical legislative steps would be necessary for making landfill minimally viable for waste-to-energy purposes?
I'm not sure if I understand the question. Which legal steps are necessary?
What technical legislative steps would be necessary for making landfill viable? For example, as I know, in Europe, have high taxes for landfilling. Just to avoid landfilling, you have another suggestion?
Yeah. The tax way is one solution. So countries like Great Britain or Poland, which have landfills, but which want to reduce the landfilling, they choose the way of taxes. We are not supporting this way because we want a very clear decision that no public euro from the European Union or other states goes in landfilling. But if you have the landfillings, there will be some interests who are looking for a profit of the landfill. It doesn't make sense to give a city or a region in Croatia or wherever a landfill and then not allowed to work with it. So the better solution is to say, listen, we want with the waste management hierarchy, with the waste hierarchy, we want a society combined of recycling and waste to energy. These are the two ways. You have time from now, 8 years or 10 years, to build up an infrastructure for this. You will get perhaps support of the European Union to build up an infrastructure, but then the decision is clear, the landfills will be closed. And we are working now with what waste is in it, how too expensive is it to get it out, how long do we need to bring back the land to the cities to build up other infrastructure on it. So the decision is better, clear cut for landfilling, not today, but in, let's say, a decade.
Oh, that's great.
I like to add something on this. Can you hear me?
Yes. You can.
I think in Germany and in Holland and Denmark and some other countries, the system has succeeded because the people have more discipline and are more thoughtful. They're thoughtful of the environmental. In other countries, the government had to intervene. Like, for instance, in China, the government intervened. In Japan, the government intervened by putting very high landfilling tips, cost $200 a ton. So in a country that I'm familiar with, because for 20 years I tried to spread the gospel, is Greece, and nothing has happened in Greece. Despite the fact that high GDP, they have not followed the directives of the European Union, and they're paying fines. And the citizens are to blame, I think, in a way, because they oppose anything new. Maybe it's not going to work and so on. There's no discipline that. So that's one thing that in Brazil you would have to overcome. Get the people to understand and to support. Then the politicians would follow up, to understand what is much better and what is not.
May I add something, please?
Absolutely.
May I add something?
Okay, that's great.
And now we come to the point, first Green Deal, and then to support the economy after Corona. Which kind of economy do we want to support? Do we want to support the old industry or the new society? If you now says, okay, let's give the regions in Greece and everywhere in European Union, let's give them the money to build up waste to energy and recycling facilities. Then we have the investments we need, and then we have the alternative, and that's necessary then to stop landfilling. To convince the people, I think, is not the biggest challenge. Even in Greece, not. It's a question of money. Who is paying for what? Do the regions in Greece get public money for a landfill, or is very clear no euro for a landfill, but 90% of the investments for waste to energy? Then you have the solution.
I agree with that, and I think the new Prime Minister of Greece has committed himself to change the situation, because in Greece, Greece has so little land. There's a lot of mountains and rocks, but the land where you can put landfills and you can put other things is little. It's like an island, you know. So, and to use the land for landfilling is criminal, really. So I think the new prime minister is going to try to do some of the things that Peter mentioned.
Thank you. I have another question. Monica Risi to Tenos, Dr. Tenos. What about solid waste from sewage treatment plants? What is the experience?
Yeah, so in a few cases, we've seen actually the co-combustion of sewer sludge. Even if it has actually a low calorific value, it can be co-combusted in conventional waste-to-energy plants. And this was actually typical what we saw actually in China, where most of the plants were built and they had actually a separate line for the sewage, which was actually dried and then co-combusted in the waste-to-energy plant.
If I may add there, in the European Union, there are at least 60 plants that co-combust. There's no problem whatsoever to co-combust sludge, you know, with municipal solid waste. So people are doing it. The same with medical waste, by the way. You know, medical waste, about 40 plants co-combust in Europe, medical waste.
That's great. Another question for Dr. Tenos from Juliana Mareko. Waste-to-energy as a distributed generation has any international experience?
I'm sorry, I didn't understand.
I have to exchange it. It's a question for everyone who can have their answer. Distribution generation in Brazil is a few plants that have 5 megawatts of capacity. For me, it's not so distribution because you have in our law, the distribution generation is the plant that the power is, the electricity injection is in the middle of the city or close to the city. The system of the distribution system is different. That in Brazil we have a lot of hydroelectric power plants that are very far from the city, and they use a transmission system to transmit the electricity to the distribution system. And I think that the question is, if you have few plants of waste to energy with 5 megawatts of capacity, the power plant.
In other words, if it's better to have one plant with 10 megawatts, is that what you're asking?
It's 5 megawatts capacity power.
They're small. These are small plants, yeah.
Small plants, yes.
But you know, in Japan, they have many small plants because they have a legislation that does not allow for municipal solid waste to be transported to other cities.
Oh, okay.
So every city has to have, but this is not the best way. I mean, if you can integrate and have a bigger plant, but it can be an advantage. But of course, if you have hydropower, that's a disadvantage because the price of electricity is lower than for the waste to energy plant. You know, competing with a very low cost source.
Yeah. I have another question here also for Dr. Temelis. And I think one major point that we have seen here in all of 3 presentations actually is that there's a big misunderstanding in Brazil, because when we think about waste to energy, there's this myth of just burning waste and not recycling. And as a matter of fact, as you have showed, Professor Temelis, the countries with the highest incineration rates are actually the ones also who usually are mostly recycling. And that sounds maybe sometimes a bit of a paradox for some people. They say, okay, wait, but you're burning our waste. And we have this reality and this misconception in Brazil. How would you explain this for our public, for example, in a very simple way? How is waste to energy directly related to higher recycling rates? Also coming to that point and adding the fact that what Mr. Bortzala says also, we cannot have 100% recycling. We need to find this balance. And as Mr. Peter Kurt also said, we need to make something which makes sense economically and environmentally. How would you explain this for a big public in Brazil, for the people who are getting to know waste to energy better?
You know, in America, US, United States, there are about 500 municipalities that are supported by these 72 plants. This gives you an idea that 72 plants serve 500 municipalities. And the question is why these municipalities chose, some of them paid for the waste to energy plant when it was cheaper to put a landfill.
Yeah.
It was environmentally conscious, patriotic. I don't know how to, but you put it this way. Let's say that you recognize by visiting a landfill that landfilling is not the best way to deal with waste, right?
Absolutely.
Then you try to do the best you can. You start with recycling. Composting also. When Yuri comes to New York, I may take him to my little hometown of Sandwich in Cape Cod. They're doing a wonderful job with providing for composting, providing for recycling, and then they had to go to landfilling or waste to energy.
Money.
Yeah.
If you want to reduce landfilling, there are only two ways: by recycling, I include composting, and by waste to energy. So you increase as much as you can, and that's what has happened. And then you increase recycling, and then you increase waste to energy. And there are entire states who have done this. I give you one: Connecticut.
Okay.
Connecticut only landfills 20%. The United States landfills 63%, you know. But still they landfill some, but at least they went from first recycling, trying the best. There is a documentary that I want you people to see. It's on Fireline. It's called Fireline. I'll send you the on public television, and where they followed the plastics that were being recycled. And I'm sure in America, but I'm sure the same thing happens in Germany. They were collected and they were sent to China, but they were not recycled. Some of them were, people picked up some stuff, and the rest either were left landfilled or set on fire. So China does not want any more recyclable materials.
That was before the ban, right?
I'm sorry?
That was before the ban.
Yeah, that's what brought the ban about, because you know, they looked at it and said, is it good for the country? Of course, China has the advantage of a very authoritarian government, you know. I don't recommend it to others, but I mean, but Japan, democratic society, still they set up very strict rules for that.
May I add something, Ruben?
Okay.
Yeah, Mr. Kurt, thank you very much.
You have to keep in mind that recycling very often is more expensive than waste to energy. If you have a complex plastic material with different plastics in one product, you have to pay in minimum 70 to 80 euro for a good recycling process. That means waste to energy very often is cheaper. And there is an old saying, waste follows money. If you offer the cheaper ways, the material will not go to recycling. We don't have a problem with high recycling quotas, 80, 90% with glass, with paper, with scrap. We have problems with plastic, with minerals, with electronic devices. And this has to be very clear. We need politics. We need politics because we need laws. As I mentioned, we still would have landfills in Germany if the parliament wouldn't have forbidden it. And we are talking about recycling quotas, and that's not an obligation for the waste management companies, but for the producers. Mm-hmm. They have to produce things which allow recycling quotas of 64%. And the last word to China. China is exporting the cheapest and the worst plastics all over the world. Yeah? No one asks which kind of plastics is China exporting. Everyone talks about they don't want their plastic waste back. China is exporting 5 times more plastic than it was importing 3 or 4 years ago. So that's a very interesting point. Are we only looking at the quality of the recyclates, or are we also looking at the quality of the plastic products? This has to be changed.
That's great. Thank you for your comment. I think that's very, very thoughtful.
If I may add something also, and there's actually a big misconception, because people think that we're talking only about a few types of plastic materials, like there may be like 5 or 4 or 6 or something like that. However, according to the American Chemistry Council, there are over 10,000 different types of plastic materials.
Yes.
Obviously, one solution doesn't fit all.
Exactly. Exactly.
No, we have one question.
By the way, you know, I think it also goes to, you know, Thanos mentioned the second law of thermodynamics. Yeah. If you look at the scientific principles, you know, there are ways that are indicated. For instance, for electronic materials, they could go to a smelting furnace, copper smelting, for instance, and they do. There are plants in Hamburg, you know, and in Sweden. Why? Because you, in one shot, you recover the copper and anything that's soluble in copper, and you have a system already of separating the impurities from the copper. They already exist. You don't have to buy a plant. So electronics, for instance, could go there. But trying to do the impossible with plastics, with like thousands of types of plastics, that doesn't work. And frankly, it's difficult to work for pyrolysis of plastics now, because the cost of oil is so low. Why bother to make oil from plastics? You know, Thanos and I are working on that with India, but right now with the low price of oil, it's problematic.
You have to convince the chemical industry in Germany.
Yes, that's it. I have a question. It would be interesting because we're discussing about the plastic. Flavio Tigal from Sweden say, Dr. Botsalas, I totally agree that waste to energy is better option to municipal solid waste treatment, but considering the circular economy, material chemical recycling should have a higher hierarchy. Would you agree?
You're addressing whom now?
If we had the technology that were really proven and dominant, and we have seen it actually operating for more than 1 year, over 90% of their time, then maybe yes. However, with regard to the reality and what can be pragmatically be done, at the moment, waste to energy is the only prominent technique. And also about the utilization of plastics that you mentioned, in Germany, which always paves the way in this field, recently, I mean, they are building plastic to energy plants. They're using either BFB, fluidized beds, to recover directly energy from this high calorific value material.
Well, this is, Thanos, this is something we suggested for India and China. But yeah, that's a good thing that's happening.
Dr. Termes, we have the final question. Flavio Tigal from Sweden said, Professor Termes, when mixed plastic is recycled is not working, that is when gasification comes. It will convert all the plastic to syngas. Do you agree?
If you could separate, source separating plastics, then gasification or pyrolysis makes sense, better than the combustion. But as Thanos said, it has to be, right now they are not economic. I'll tell you why. We have looked into this. 1 ton of mixed plastics, you can produce at the most 4 barrels of oil, 4 barrels. Now, the barrel of oil now is $25, so you have $100. That's not a lot to pay for collection. Collection alone would cost you $50. So, but if it was $75, then it would make sense. So gasification and pyrolysis, right, they have not shown to be viable in any large scale. Some plants were built in Japan, and then some of them are still operating, but not too many. So I don't hold faith in something like that happening unless the oil price goes up. Then you can make, gasification, or you can make pyrolysis.
And also it depends on the perspective. If you want actually to be an academician, then yes, education and pyrolysis will give you actually many papers. However, in terms of deployment, at the moment only waste to energy is proven and has been actually deployed in several places in the world.
I have to charge my computer, so I will excuse myself for a minute.
And about gasification also, we recently had a failure in the deployment of such technology in the UK. Thames Valley were after about the champions of our field. After trying to build the gasification plants for about 4 or 5 years, they concluded that we cannot really do so.
I think the background for the discussion about chemical recycling is different because we have in Europe very high laws of recycling quotas for the recycling of plastic. And if the chemical industry would be successful in accepting chemical recycling as a recycling process, it would be much easier to reach the recycling quotas without more efforts for the material recycling. This is the background.
Thank you, Peter. Thank you, everyone. It was a very high discussion about waste to energy, circular economy. And we have to thank you, Dr. Temlis. We have to thank you, Dr. Botsalas, Dr. Peter, for the presentations. And we have to say that ABREN make a good job in Brazil to change the regulation. The hierarchy of waste is not so clear in our law, because we say that after recycling, go to the waste treatment and waste treatment, and next go to the landfill. And landfill is an environment appropriate manner to treat the waste. In Brazil are just looking for the landfill, because no one knows what waste treatment, because the law didn't have the definition about it. In our decree, the regulation don't define it. We don't have a regulation, a federal regulation about waste management like you have in United States, in Europe, and in China, in Japan. We are working very hard to create these regulations, and our project of law, a bill of law, is to change our federal law just to put energy recovery in the law by digestion, sterilisation, gasification, pyrolysis, and by digestion, just to show what's the way to treat the waste and to reduce the organic fraction in the waste in 15 years, like you have in Europe, that we reduce to 35%, are going to 10%. Maybe the match is going to 1% in the future to go to landfill, the organic fraction of the waste. And we are creating some incentives to have a good TPP, a sufficient TPP, and to have some auctions to contract for a long-term contract the energy, the electricity from the waste-to-energy plants. With this tariff and a long-term contract, you can have a project finance, and it's more easy to the companies in Brazil to invest in waste-to-energy plants, because you can have guarantees to the bank, not another guarantees. You can create a company separated with this business. You have low risks in this operation. And our electricity market is doing well because we have auctions to contract energy with long-term contracts, 30 years, 25 years, 20 years. And this contract you can give with a guarantee to the bank. And our electricity market is a AAA investment all around the world. And you can be the same, bring the same model of investment to the waste-to-energy, to the waste management sector. And we have another sanitary law that are changing and creating a tariff that we can put inside the water bill. It would be very awesome because we have nowadays a tax. This tax of waste are going to the municipalities, and municipalities can spend with another in another area, not just to using specifically to treatment the waste. It's our job. We are thankful for everyone. It's the final. If you want to say something, just 1 minute to everyone.
Are you planning to publicize this the results of this conference? Are you going to publish them on the web, let's say?
Okay, we will do it. I will send the link of the video and the presentations of everyone.
Thank you very much. I learned a lot. Thank you very much for arranging. And very nice meeting you, Peter. I hope we meet in person in Berlin.
Would be great.
I have not been there since before the wall fell down.
You should come. The city has changed a little bit.
Yeah, I gave a lecture at the University of Berlin years ago about copper making. Bye-bye, everybody.
Thank you very much.
Mr. Kurz, it was a pleasure. Guys, thank you very much for the opportunity, and we'll be in touch soon.
Thank you very much, everyone. It was very thoughtful. Okay. See you, everyone. Thank you, Yuri. Thank you, Mr. Peter Kurt. Have a nice night, everyone.
Thanks.
Likewise.
Bye-bye.
Thank you very much.
Bye.
Thank you very much.